Welcome to video lecture on differential equation. Yesterday we derived the Cauchy-Euler equation. That means how to solve the differential equation which is in the form of Cauchy-Euler. I hope you are following the video lectures. If you find any doubt or any queries, please ask me in the Google Learning app or in WhatsApp. Yesterday we solved two problems in Cauchy-Euler equation. Today we solve some more problems which are slightly different from yesterday. Once again I recall what we learned yesterday. What is the Cauchy-Euler equation means? I am here showing you the second order Cauchy-Euler equation, that is some constant into x square into d square y by dx square plus a1x into dy by dx plus a0 into y is equal to q of x. The easiest way to identify the Cauchy-Euler equation is x power of the value is same as the order of the derivative here. See here, x square means d square y by dx. X power 1 dy. Here there is no x, that means x power 0. Here also derivative also 0. If we go to the general order, that is x power n derivative of n, x power n minus 1 derivative of n minus 1, x power 1 that is derivative of first order. Okay, if any differential equation of this type, we can easily conclude that this is Cauchy-Euler differential equation. And what is the how to solve this type of equations means, first we introduce one more variable called t, that is x is equal to e power t, we assume. Then t will be ln of x and 1 by x is equal to dt by dx. We change the differential equation of independent variable x into independent variable t. Then we solve in t, again we'll change t to x. That gives the original differential solution to the original differential equation. And one more thing in Cauchy-Euler equation is, here this is the form. Suppose x dy by dx means we have to write d1. X square d square y by dx square means d1 into d1 minus 1. X cube into d cube y by dx cube means d1, d1 minus 1, d1 minus 2. Where what is d1 means d by dt. Yesterday also I said that in some books instead of d1 they use theta, but the meaning is same. Okay, yesterday we solved two problems and today we solve some more problems. Let's move to the problem. Yesterday we solved only second order differential equation of Cauchy-Euler type. Today we are discussing third order, that is x cube d cube y plus 3x square d square y plus x dy plus y is equal to x plus log x. Let's first of all we conclude whether it is Cauchy-Euler equation or not. See here, x power 3 derivation of 3, x square, here also derivative 2, that means 2 times derivative, x power 1 d power 1, here there is no x, there is no derivative. So easily we can conclude that this is of Cauchy-Euler equation. So what we have to do, we have to introduce one variable t, which is x is equal to e power t. Then t will be ln of x and one more variable, that is d1. d1 means what is that? D by dt. Okay, we change this one to in terms of d1. That means we are changing the differential equation of variable x into variable t. So x cube d cube, instead of x cube d cube we are writing d1 d1 minus 1 d1 minus 2 plus 3 as it is. X square d square means d1 into d1 minus 1 plus xd means d1 plus 1, y means 1 into total y is equal to, here x is equal to e power t, log x or ln of x, that is equal to t. If I simplify this one, I will get d1 cube minus 2d1 square minus d1 square plus 2d1 plus 3d1 square minus 3d1 plus d1 plus 1 into y is equal to e power t plus t. If I get terms will get cancelled, and the last value will be d1 cube plus 1 into y is equal to e power t plus t. So the auxiliary equation will be m cube plus 1. Why? Because here d1 cube plus 1 is there. Instead of d, I am substituting m to find the roots. M cube plus 1 is equal to 0. This is in the form of a cube plus b cube. So it becomes a plus b into a square plus ab plus 1 is equal to 0. That is m is equal to minus 1 and m is equal to 1 plus or minus root 3I by 2. Here we got complex roots. So we have to write the complementary function for complex roots also. So yc is equal to c1. Here minus 1 means e power of minus t plus, here the real part is 1 by 2. Imaginary part is root 3 by 2. So e power 1 by 2t into c2 cos of root 3 by 2t plus c3 sine of root 3 by 2t. Now the important thing is, again we have to change t variable to x. That is c1 x power minus 1 plus this value becomes root x e power 1 by 2, that is x equal to e power t, then x power 1 by 2 will be e power 1 by 2, that is x power 1 by 2 means root x. C2 cos root 3 by 2 t means ln of x plus c3 sine root 3 by 2 t means ln of x. Okay, so next we have to find yp value. Yp is equal to 1 by d1 cube plus 1 into e power t plus t. Here two terms are there, so we split this by a particular integral into two terms, sum of the two terms, 1 by d1 cube plus 1 into e power t plus 1 by d1 cube plus 1 into t. So here e power t something is there. If I substitute, that means e power at form, I can substitute a here in place of d. Here a value is 1, so that is e power t by 1 cube plus 1. So this is in the some variable power n, x power n form. So what I am doing, I am bringing the denominator to the numerator. It is 1 plus d1 cube whole power minus 1 into t. So this value becomes e power t by 1 cube plus 1, 2 plus this is the expansion of 1 plus x whole inverse, that is 1 minus x plus x square and so on. I am not writing all those terms. Why? Because here the term is only t. 1 into t will become t, and d1 cube of t means derivative 3 times derivative of t. One time will be 1, second time will be 0. So no need to write all those terms. That's why I am skipping all those terms. So e power t by 2 plus t into 1t, remaining all zeros will come here. So again we have to change this one into x. E power t means x by 2, t means ln x. So this is our particular integral. So the final general solution will be y is equal to yc plus yp, and we have to write the yc value as well as yp value. Okay, and we jump to the next question here. These are the exercise problems. See here, slightly different from the previous one. 61, this is the question number 61 in the exercise. X power 4 d cube y by dx cube plus 2x cube d square y by dx square minus x square dy by dx plus xy is equal to 1. Okay, so one thing, here x power 4 is there, but derivative is only of order 3. Here x cube is there, but derivative is of only 2. Here x square is there, but derivative is of only 1. Here x power 1 is there is no derivative. Okay, so what we will do, here x cube must be there, here x square, here x, here there should not be any x. So we divide with x, then becomes x cube d cube plus 2x square d square minus xd plus 1 into y is equal to, here I am dividing total equation both sides with x, then it becomes 1 by x. See here x cube d cube, x square d square, x power 1 d power 1. So we can conclude that it is Cauchy Euler equation. So we know the procedure how to solve for the Cauchy Euler equation. So introducing x is equal to e power t, then t is equal to ln of x, and d1, capital D1, which is equal to d by dt. That means we are going to change this total equation is equal in terms of independent variable t. Okay, so x cube d cube, so d1 into d1 minus 1 into d1 minus 2 plus 2 into d1 into d1 minus 1 minus d1 plus 1 is equal to e power minus t. So it becomes d1 cube minus 3d1 square plus 2d1 plus 2d1 square minus 2d1 minus d1 plus 1. If I multiply this one, I get this value, and plus 2d1 minus 2d1 gets cancelled. Here actually the right side q of x value is 1 by x is there. So we are introducing x equal to e power t. That means 1 by e power t, it becomes e power minus t. So the value here d1 cube minus d1 square minus d1 plus 1 into y is equal to e power minus t. So the auxiliary equation to find the complementary function, m cube minus m square minus m plus 1 is equal to c. The trial and error method to find the roots, have substituted m is equal to minus 1, and this total value becomes 0. So m is equal to minus 1 is a root for the given equation. So we have to find the remaining. Here it is a cubic equation, that means we got only one root. We have to find the another two roots. So by the division method, m is equal to minus 1, I am writing the coefficients of our equation in the decreasing order. That is, m cube coefficient is 1, m square coefficient is minus 1, m coefficient is minus 1, constant is 1. Keep 0 here, 1 into 1 plus 0 1, 1 into minus 1 minus 1, minus 1 plus minus 1 will be minus 2, minus 2 into minus 1 2, minus 1 plus 2 minus 1 plus 2 1, 1 into minus 1 will be minus 1. In the last game, if you add this one, you get 0. So this total equation can be written as m minus 1 is a root, means it becomes m plus 1. M square minus 2m plus m plus 1. M square minus 2m plus 1. See the second function, it is square of some term m minus 1. So the roots will be m plus 1 gives m minus 1. M minus 1 whole square gives root 1 2 times, 1 comma 1. So the yc will be c1 e power minus t for minus 1, and 1 comma 1 c2 plus c3 t e power t, because it is repeating 2 times. So c1 x power minus 1, again I am changing to the x, e power t is equal to x, so e power minus t will be x power minus 1. c t into e power t, that is c2x. c3 into t e power t, so e power t is equal to x, t is equal to ln of x. So c3x ln of x. Let's find out the particular integral for this one. So yp will be 1 by d1 cube minus d1 square minus d1 plus 1 into e power minus t. For easy simplification, I have written this one as d plus 1 into d minus 1 whole square. No need to do again for this one. Already in the auxiliary equation, we got this value as m plus 1 into m minus 1 whole square. So the same value we are using here, d plus 1 into d minus 1 whole square. So it is in the form of e power at. So if I substitute minus 1 here, minus 1 plus 1, it becomes 0. So I am keeping as it is, d plus 1 into. For the second value, I am substituting d is equal to minus 1. E power minus t into minus 1 whole square. This value becomes 1 by 4 e power minus t into 1 by d plus 1. See here, it is in the form of here 1 by d minus a whole power n into e power ax. If I substitute here, it becomes 0. Then the formula is x power n by n factorial into e power ax. That means here the total power of this total term is 1. So 1 by 4. So the value becomes 1 by 4 into t power 1 by 1 factorial e power minus t. Again we have to change the t values into x. Then 1 by 4 e power minus t, e power minus t will be x power minus 1 and t will be ln of x. So the total solution will be y is equal to yc plus yb. C11 by x, C2x plus C3 ln x plus C4 1 by 4x into ln x. See here, yc, I forgot to write one term. Please write that one. Oh, sorry, I have written here. C3x ln x, right? Okay. So the next problem. So you see here, x square d square plus 2xd minus 20y is equal to 0. Sorry, is equal to x plus 1 whole square. Check here, x square d square, x power 1 d power 1. There is no, that means x power 0 for constant you may assume. So directly we can say that it is Cauchy-Euler equation. So introduce t variable as x is equal to e power t, then t is equal to ln of x, and d1 will be d by dt. So the introduce d1 instead of x square d square, it becomes d1 into minus 1 plus 2d1 minus 20 into y is equal to x is equal to e power t plus 1 whole square. So if I simplify this one, I get d1 square plus d1 minus 20 into y is equal to e power 2t plus 2 into e power t plus 1. So the auxiliary equation becomes m square plus m minus 20 equal to 0. If I simplify this one, the roots I got 4 comma minus 5. So yc is equal to c1 e power 4t, c2 e power minus 5t. E power t means x, e power 4t will becomes x power 4. Similarly, it becomes x power minus 5. Let's move to the yp. Yp will be 1 by d square plus d1 minus 20 into e power 2t plus 2 e power t plus 1. Here it is the sum of 3 terms. So we split the total yp into 3 terms. This value will be same. That is, I am splitting this into 2 terms, d1 minus 4, d1 plus 5 into e power 2t, e power t and e power 0t. So e power 2t, instead of d1 I am substituting 2, that is if it is non-zero. So here 0 term won't come, 2 minus 4 into 2 plus 5 plus, here instead of d1 you have to substitute 1, e power 18. Here a value is 1, 1 minus 4, 1 plus 4. Here the constant term 1 I am writing it as e power 0t. So the a value is 0. So I am substituting 0 instead of d1. So 0 minus 4, 0 plus 5. If I simplify this one, e power 2t, 7 into minus 2 minus 14, 2 e power t, 6 into minus 3 minus 18, here it becomes minus 1 by 20. So the yp value minus x square by 14 minus 1 by 9x minus 1 by 20. So the y value, general solution for the given differential equation will be y is equal to yc plus y. Okay, that's all for today, and I hope all of you are following my video lecturers, and the notes will be provided to you after the completion of the course. And don't go anywhere, stay home, stay safe.